Okay. The Z with the Z. Okay, so let's look at this. Remember the other day in class, I had my two arms out. Actually, Jill and I were holding hands. And we noticed that if I apply a force in this direction, I cannot get this to rotate. This force has to be something like this to cause a rotation, or the force has to be like this to cause a rotation. But if I apply a force parallel to a line, the only thing I can do is pull that line. I can't cause it to rotate. Right? So everybody put your hands out. If you apply a force in one direction, you can't cause this to spin. But if you apply a force like this, put your force somehow, and it causes a moment like this, right? Put your hand, so I'm putting this hand up here, this is my axis. I'm taking this and I'm putting it like this. If my left hand is going this way, it's going to cause a rotation of my arm. But if I'm only pulling, if my force is going like this, it can only pull the other arm, it can't rotate it. So if a force is parallel to an axis, it can't create a moment.
So are we talking about, for example, for X, are we talking about point A? How is rotating about X?
So what we're doing is we're comparing the direction of the force to the direction of the moment about point C. So so what I drew here is I drew the X, Y, and Z directions of the force. And the question, remember the question is find the moment about point C. So, what?
I think.
Well, let me just finish my thought. So I'm trying to find the moment about point C. So X through C is here, Y through C is here, and X through C is here. So what I'm looking at is I'm saying, okay, here's the force in the X. Does the force in the X create a moment in the X along C?
No, it can't.
And it can't because they're parallel. Can the force in the Y create a moment along this is a Y here, right? The Y axis through C, can it? No. Can the force in the Z create a moment in the Z here? No, because they're parallel. Okay, Paul, now you could interject what you were going to say.
What you said was, you said the force, the X component of the force.
The X component of the force
You said it can't create a moment.
cannot create a moment about the X.
About the X.
Through
You
C.
kind of stopped when you said that. So it does create a moment, it just cannot create a moment in the X.
That's correct. And that's why I drew this table, because we're looking at each little box in the table. Right now, we're saying the force in the X creates no moment in the X about C.
Good.
But it quite possibly creates a moment about the Y and about the Z. And then Y, so far we said it doesn't create a moment in the Y. Okay? Yeah, good? Makes sense now? So for me, it's very important that I draw the axes on the paper so I can visually see where they are. So I drew the force X, Y, and Z, and then I drew the axis A, X, Y, and Z through point C. And I don't think I drew the force X that great. Let me,
It's supposed to be parallel to the X
right,
axis.
so let me draw the rest of my box in there, because then I can draw it better. I have another sheet. Let me start drawing another one. Okay, so here's my box. So this one's not a problem. I know this is my force Y. This is not a problem. That's my force Z. How's that, better? That's my force X. And then, let's do this in blue.
And then
So now we're looking at, I want to use a marker, so it's thicker. So here, C, this is the Z axis through C. this is the x-axis through C. And that's the y-axis through C. Okay, I think that's a better drawing, right? Okay, so should I explain again? Let me know. Do you want another explanation of why force X does not create a moment about the x-axis through C? Everybody has this? Ilya, you're fine. Brandon, you're fine.
Yeah.
JJ? The force through the X. The force X does not create a moment about the x-axis through C. You got that, right?
Yeah.
Armando?
Yep.
You guys, everybody's all right? Okay, so now let's look at the next step. We're going to do one box at a time. And this is new. You've never done this before. You did 2D problems last week, but it was before the exam. And even though you had your homework due, you probably didn't spend a lot of time on it. And now we're looking at 3D. So now what we're doing is we're looking at this box. Look at this box. Remember, we're doing right-hand rule. How do we, in order to find a moment, we're trying to say it's the absolute value of the force times the absolute value of the perpendicular distance. And then we use our right-hand rule to determine the answer. So Ilya, let's do you. So we're looking at force X. Force X is right here. And let's write its value down on this piece of paper. Force X is 400. Force Y is 500. And force Z is 360. And the negatives don't matter, right? Because right-hand rule, I'm taking the absolute value of these two forces. So in order to calculate the moment about Y through point C, due to the 400, it would be 400 absolute value times the perpendicular distance. And what is the perpendicular distance? Ilya, you see it?
Yeah, 250.
Okay, so let's see. We're looking at force X. Here's force X. It's in the X direction. We're trying to find the moment about Y. Try again. So if the force is in the X, we're trying to find the moment about the Y. The perpendicular distance is going to be in what, Ilya? The Z. Right?
Yeah.
Okay, so let's see. So the force is here. We're trying to find the moment about here. Think about this. My fingers are going in the direction of the force. My palm is going towards here. What's that perpendicular distance?
180.
180. And is it positive or negative? Fingers go in the direction of the force. Palm goes towards the Y. Which way is your thumb pointing? In the positive or negative Y?
Positive.
Positive Y, so it's a positive value. So I want everybody to get that before we move on. So on this 400 Newton force, I'm trying to figure out what moment it creates about the y-axis. And it's 400 times this perpendicular distance. So everybody's almost near one person. Peter, would you move over? Joe, would you move over? Or Mark move over? Talk to the person next to you and make sure that you both figure out why it's 180. Look at the picture. So you guys talk to each other, Mark and Jill. Yeah, no, you do it, why you didn't hold it the way we did it before, where you find the unit vector, I guess you can find totally, that's the only way to do it. Well, in both cases, whether you're doing right hand or vectorial, you have to find the force, because right now you only know the value of it, which was 735 newtons. You need to know what the performance of the force on. So the first step, and that's a good one, is right, you know, saying, you gotta find the performance of the force.
Yeah.